Hi, this is Pokemon Marie with Joshua Layton, Trevor Pendarvis, and Jonathan Craig for Computer Science 3833 at the University of Central Oklahoma. Pokemon Marie. Our team implemented a game in the spirit of Pokemon in the Marie assembly architecture and C. The game is playable by one or two players and centers around a rock, paper, scissors type of battle. Between the implementations, we have analyzed assembly instruction number and length and drawn a number of conclusions about the Marie assembly architecture in x86. Our team members were Joshua Layton, in charge of programming Pokemon Marie, Trevor Pendarvis, in charge of programming Pokemon C, and myself, Jonathan Craig. I took care of expanding Marie Sim and the presentations. The design for our Pokemon Marie game, the concept of our game's design is to simulate Pokemon battles in a fashion similar to an expanded rock, paper, scissors. A user can play a battle against a computer opponent or against another human player. Each user takes turns selecting a Pokemon, and then the battle begins. Each Pokemon can defeat 5 other Pokemon in the list of available Pokemon. Should neither Pokemon defeat the other, a draw is declared.
Design. To implement implement the Pokemon battle, we use the circular hierarchy to define the winner between any two Pokemon that battle. It is as follows. John? Oh, sorry. So we have it basically set up. Each Pokemon is giving a value 1 through 11. Each Pokemon will beat the next 5 following numbers in front of them. So as you can see, Onix will defeat Blastoid, Pikachu, Venusaur, Arbok, and Mewtwo, and etc. They all follow that same pattern. And then you have it keep going on. As in, Mewtwo will defeat Charizard, Sandslash, Snorlax, Geener, and Marchop. The next 5 in front of Mewtwo will lose against Mewtwo. And it still follows the same pattern. The circular part, number 11. Since there is no following numbers after that, it will actually wrap back around, and Marchop will beat 1, 2, 3, 4, and 5.
So for implementing in Marie, that was a little more difficult. An implementation in a higher level language like C, defining a set of other Pokemon for one Pokemon to defeat is quite easy. The first thing that would come to mind is an array. So each Pokemon, could have a list or an array of the Pokemon that it defeats. But the problem is Marie has a very limited instruction set and does not have array types or anything close to it. Because of that, each Pokemon essentially has to have their own function, and each function defines the Pokemon that Pokemon can defeat. So each function contains 5 checks to see what the opponent's Pokemon is. If any of those checks return true, so in other words, if any of those checks finds out that the opponent's Pokemon is one of the Pokemon inside the function that it can defeat, then it knows that that Pokemon won. If it makes it through the entire function and no opponent was found, or essentially the first Pokemon was not able to beat the second Pokemon, then we know the second Pokemon wins. So if it makes it to the end of the function, then the second Pokemon will automatically win. This ended up in a very, very long program, seeing as all 11 Pokemon had to have completely different functions that could not be modularized as well based on Marie's nature. Also, we had to double the size of the program for the 1 to 2 player mode just because Marie doesn't have a lot of modularity options. So what we decided to do is we wanted to actually analyze the instructions. In other words, how long the programs compare to each other. So like C and Marie and x86, which is the assembled version of the C code. And we found that Marie was incredibly longer than the x86 and C, and that x86 is longer than C. This is because the less instruction sets you have, or thus options you have in a language, the longer your code's going to end up being, because you're going to have to define every single bit of logic. I mean, Marie doesn't even have anything for multiplication, division. So if you want to do something like that, you'll have to define your own function. So this really resulted in, if you can go to the next slide, please. This resulted in, as you can see by this graph, Marie being the red and C being the blue, indefinite, exponentially large program for Marie, and also exponentially more complicated. And this makes Marie extremely hard to collaborate on as well. For multiple programmers to work on one Marie file would require a large amount of comments because it's not easily readable. It's not easy to just look at it and tell what it's trying to do. You would have to explicitly define with comments or explanations. So overall, though, maybe Marie definitely, or assembly languages definitely have their place in efficiency and speed. Their disadvantages of not being easy to program in and not efficient to program in definitely outweigh that, in my opinion.
Okay, to show some demos of Pokemon Marie, here is a single-player game. Running the file, and it'll ask you to enter the number of players.
So here's a demo of the one-player mode in Marie. The first question that's asked is, how many players do you like? So we entered 1. And then the second question that's asked is, which Pokemon the first player would like? And so that's going to run, and actually our own instruction set that we created called RAND will select a Pokemon between 1 and 11 randomly. And then it'll output the winner, in this case, the human player, player 1-1. So for the AI part, we actually had to implement our own instruction set because Marie does not have a way to even create a pseudo-random number. So here you can see we're going to select Pokemon 7, and player 1 wins again. This is the C version of our demo. You can see here, this is the code that was created to compare it to. You can see the C version has a lot more printing capabilities and visual aspects. So here you can actually see all 11 of the Pokemon's names when you choose it. And there's you can actually see also the Pokemon AI chooses. This is due to C having a lot more output functions compared to Marie, who can only output one character at a time. And so next we're going to demo the 2-player version of the Marie. John, if you can go over to that.
Okay, for the 2-player version, it works in a very similar way, so we'll go ahead and run it. So right now we're going to enter the number of players. We're going to select 2-player. And then player 1 select, I'm going to select number 1, Onix. And for player 2, I will select number 3, which is Pikachu. And number 1 should defeat Pikachu, so player 1 will win. And as you can see, player 1 wins. And if we flip that around, we have 2 players. Player 1 selects Pikachu. Player 2 selects Onix. See that player 2 wins. And for the C version, if we select person versus person, 2-player, we can again Demo the same way. Select Onix first and select Pikachu for player 2. Player 1 is the victor. And this time we select Pikachu for player 1 and Onix for player 2. And player 2 is the victor. That is the demo of the 2-player version.
So overall, I think we had a lot of fun making these programs, and it really helped for us to practice our, building out our logic, especially in the Marie section, because it requires so much logical breakdown of the instructions. But overall, I think we found that assembly can be really hard to program in. While it does result in a more efficient program, Marie took up many more lines of code while at the same time being much, much more simple than the C program and less visually pleasing or useful to play. But I think overall, assembly languages might have their place, but if I were to develop an application in the future, I would not choose assembly. I would go for a higher level language.